Hello everyone, Ewan from Elixir Experts here. Today I'm going to show you how the time impact method of delay analysis actually works in action. I'll discuss its reliability in dispute resolution in a follow-up to this video. Okay, let's get into it, and please like and subscribe if you like it. The time impact method of delay analysis is a critical path method of analysis of delay events based upon the time they occur. Therefore, it provides for updating the as-planned program with progress to just before a delay event arises, and then impacting a delay event on the program. The as-planned or uncompleted part of the program is then used to forecast the completion date, and any slippage in the completion date from the updated program just before the delay event was impacted can be said to be the critical delay arising from the delay event. In order to demonstrate the method in action, I've shown an as-planned program here for the construction of two buildings, Building 1 and Building 2, each comprising a substructure followed by a superstructure. The start date is the 1st of January and completion is forecast to be the 31st of August. The program also contains logic allowing the critical path to be identified. And in this case, we can see that at the start of the project, both buildings 1 and 2 are critical to completion because both sequences are continuous and forecast that completion is achieved on the 31st of August. I've recorded the base details of the program in a table below to use as a benchmark to assess the impact of any delay events. The table shows the date for planned completion, 31st of August, any critical delay, which is likely to be 0 in the as-planned program, and what is critical at the time of the analysis, the substructures of Building 1 and Building 2. Next, a delay event of 2 months or 61 days occurs on the 1st of April. So the first step is to update the program with progress at the 1st of April to assist in identifying what was critical at the time. When progress is added to the program, we can see that the contractor had progressed the substructure of Building 1, shown in blue here. But we can see there had also been a 1 month or 31-day delay before the substructure of Building 1 could be completed. Building 2 substructure progressed as planned. This 1 month delay to Building 1 pushed planned completion out to the 1st of October. And since the substructure of Building 1 is driving completion, it is critical at this time as recorded in the table. When the 2 month or 61-day delay event is impacted on the progress program at the 1st of April, the completion date moves out by just 30 days from the 1st of October to the 31st of October, as shown in the table here. It can then be said that the effect of the 2 month delay event is only a 30-day critical delay to completion, i.e. there is a critical delay of 30 days as a consequence of the delay event. I will just toggle the impact to allow you to see the change clearly. The reason why the 61-day delay only caused a critical delay of 30 days to completion is that it was not initially critical and effectively had 31 days of float before it started impacting the completion date. However, is this right? The answer is it could be, but since the delay is impacted on a prospective basis, it may turn out later to be inconsistent with what actually happened. To this extent, the forecast delay may have been overstated and the actual delay may have turned out to be just 1 month or 31 days. If this 31-day actual delay is impacted on the program, it results in the completion date not moving out further than the 1st of October, meaning the time impact method of delay analysis did not reflect what actually happened. That's it. I'll leave it there and look out for the follow-up to this video where I further discuss the reliability of the time impact method of delay analysis and what to look out for. Thank you very much and have a great day.